Imagine you're testing a travel booking web app with a calendar widget that's entirely built in JavaScript. This widget doesn't use traditional input tags. Instead, it dynamically renders calendar grids and navigations. The QA team needs to ensure that once the user selects both departure and return dates, the search button becomes active. Your test case must not only interact with a complex DOM, but also remain stable across varying load times and element IDs. How would you structure your automation to deal with non-standard elements and make this interaction reliable? Absolutely, this is a situation we often encounter in real-world travel or event booking platforms. Let me take you into a real-time scenario I had while testing a popular flight booking web app. The page had dynamic JavaScript-based calendars, very modern-looking, but tricky to deal with. The challenge was, these date pickers didn't follow standard HTML input behavior. Every time you clicked the field, a new part of the DOM would be generated, often with random IDs or classes that changed during each render. So to automate this efficiently, I started by breaking the test case into 3 clear parts. First, I ensured that the calendar UI elements were fully loaded before interacting. Rather than relying on static waits, which often lead to flaky tests, I used smart waits that monitored the actual visibility of key DOM nodes. It's like not jumping into a moving train, but rather waiting for it to slow down just enough to step in safely. Then came the date selection part. Since the calendar elements changed frequently, instead of targeting them with exact IDs or class names, I wrote a flexible locator strategy using relative XPath and parent-child hierarchies. Think of it like walking through a crowded market where the stalls move every day, but you still find your way using street signs and neighboring landmarks. Now here's where it gets interesting. Even after selecting both dates, the search button didn't always activate instantly, sometimes due to client-side scripts still running in the background. So I didn't just validate the button by checking its clickable state. I waited until the button's internal class changed to indicate it was enabled, almost like checking if a traffic signal turned green, rather than just assuming it did. To sum up, I made the script resilient by focusing on 3 things: timing, flexibility, and observability. Instead of hard-coded waits and fixed locators, I built it to observe behavior, exactly how a real user would, ensuring it worked reliably, even if the calendar looked or behaved slightly differently the next time. That's how I designed a robust test for flaky and complex date pickers in a live travel booking environment.